Good morning, everyone. Welcome to Smart Teaching Online, which is proudly sponsored by BT, Africa Holdings, by Disability, AstraTech, and Department of Education. For you to be part of today's assessment, you have to log in to www.hellosmart.com. You have to sign up as a guest, type in your ID or your class ID, which is 598751. Add your name. Okay, yesterday we was busy with the power. We talked about, we defined power, we defined all the vocabularies that we expect under power. We have done some of examples. We have done one activity yesterday. So today we have to do the second one before we start with the average power. Okay, if you can just look at this one, I will just read it for you, and then you have, I will give you 5 minutes. Let me do this quickly. Madeline and her family went on a skiing trip. The drag lift pulled Madeline up a 20-degree slope. The pulling wire was at an angle of 15 degrees to the slope, and some of the forces acting on Madeline are the pull of the drag lift wire, which is P equals to 320 Newton, and then the second one, the perpendicular push of this, where N, a normal force, equals to 620 Newton, the frictional push of this F is equals to 53 Newton. Okay, the last one, the pull of the Earth, where weight is equals to 750. If you can just look at this, I try to highlight them so that you can move fast. All right, the work done by each force on Madeline, as she is 30 meter up. 30 meter up, the slope is this. This is the multiple choice. What I need you to do, you have to do calculations. We have A up to D. Okay, I'm just giving you only 5 minutes from now. 5 minutes, so that we can start with average power after this exercise. Okay. 5 minutes. 5 minutes only. 5 minutes only. 5 minutes only. Four minutes left. 4 minutes left. Okay, 4 minutes left. 4 minutes left. Three minutes left. 3 minutes left. 3 minutes left. Two minutes left. 2 minutes left. 2 minutes left. A minute left. A minute left. Time up. Time up. Okay. Hopefully you are done because it's not much. What is needed here is for you to calculate the work done of each force. Okay. I tried to read them all to you so that you can see what I'm expecting from you. And then let us look at this. I will try to move fast so that we can start with the average. Okay. The given information here, we have to start with the first pull of the drag lift wire, which is P is equals to 3 Newton. Okay, now we have to go back to the formula of work in order for you to calculate the work done. And then the forces are given. So the distance is also given, which is 30 meters up. And then theta is also given. If you can just look up there, we have 15. Okay, what I'm going to do, I just want to show you these answers. Okay, let us start with the first. The work done by the pull, where the force is equals to 320. You have to say W is equals to Fx cos theta, where the force is 320. The distance there is given is 13, and then theta there is 15 degrees. Okay, if you can just go down, you have to use your calculator, substitute with the values provided for us up there. We have 320 for force, multiplied by 30, multiplied by cos 15 degrees. You're just going to get 9.3 kilojoules. Okay, if you can just look at that, you're going to have 320 multiplied by 13, multiplied by cos 15, which is equals to 9.9272. If you can just look at that, it's 9,272,88. We just want to reduce it. That's why I wrote 9.3 kilojoules. You know how to come up with 9.3. You have to start from, let me show you, it's approximate. Let me show you. But we can't just waste our time. It's approximately this. It's 9,200 and not point. It's 9,272.88. In order for you to get 9.3, you have to move from here to 3 in order for you to get the small letter K, that is kilojoules. I hope you know why I got, okay. All right, let us go up and check. We have which is 9.3. We have number B, which has 9.3, number C 9.3, number D has 9.3. Okay, let us carry on with the perpendicular one. Okay, perpendicular contact push of the snow. In other words, if you have a perpendicular, we know from the definition that perpendicular, if you have a perpendicular, we are going to have a 0 joules. So we can't just calculate because we know, and then from the word perpendicular, I say W perpendicular is equals to 0 joules. Okay, then the third one, which is the friction. This is the negative work. This is the negative work. If you want to calculate a negative work, I told you that you have to use 180. Okay, because friction is always opposing the motion of an object. All right, W push, which is equal to the same formula of work. All right, but we are going to change only the theta there. The theta there is 180. If you can just look at that, we have to substitute with the given values up there. We have the force of 53. We have 53 frictional force there, and then distance is the same as 30 multiplied by cos 118. For 118, for us to get the negative, because it's friction. The moment you come across with friction, you must know that you are calculating the negative work. It's always opposing the direction of the motion, which is minus 1590 joules. In order for you to get the kilojoules, I showed you above there, we have to move from 0, 9 to 5. That is why we have minus 1.6 kilojoules. Okay, if you have these three, you can see that which one? Number A is out. Number B is also out because the second one is perpendicular, supposed to be 0. Okay, the third one is 0 and minus 1.6. Obviously, here we have minus 7.7 kilojoules. The answer there is number C. Okay, let us move first to our today's topic. Let us carry on. Subtopic of power. Let us carry on. Today we are going to look at the average power. I defined average power yesterday. Okay, I said is the amount of work done during a period of time. In other words, you're just going to use the same formula that we have used yesterday for P equals to W over T. This time you have to say P sub of average, which is equals to W over time. W stands for work done by the forward force of the object and is going to be measured in joules. What about the T? That is the time. The time for which the object maintains a constant speed measured in seconds. Okay, we have talked about the units of W, units of power, units of time. Okay, now we have to look at this. All right, average power. I said we're supposed to have a work done and a time. If you don't have work done, you are not going to calculate the power, and time is supposed to be provided. If they are not provided, you have to calculate them. All right, the work done by the forward force F of the object is given by W equals to, this is the normal force, this is the normal equation of work done that we're using since we have started with this chapter. Okay, W equals to the product of force and distance of force and displacement. If you can just look at this, the theta there, theta is equals to 0. If it's equals to 0, we're expecting the positive work done. That is why we have F changing X. For F changing X here, it tells us that the theta is equals to 0. Don't forget that, because we're dealing with positive and negative only. Positive work done and negative work done. That is why we have W is equals to F changing X cos theta is equals to F changing X. That is the displacement and the force. That is the product of the force applied and the displacement. What we are going to do now, you have to substituting equation 2. This equation 2 into equation 1. Okay, we get the following. Which one is equation 1? Let me show you the equation that we have. That is P average, which is equals to, earlier there we said W over T. That is W over T. W over T. Now we know the W. Our W is equals to the product of the force and the displacement or distance, which is equals to F changing F changing X. If you can just look at that, I just take this and replace our W with the product of the force and the displacement. Okay, divided by time. It's still the same. It's still the. This is what we have here. Okay, I need you to look at this because maybe you can ask yourself, where is it coming from? Okay, that is W over time. That is W over time. That is why we have F changing X over T there. Okay, but we know that this part here, we know that this part here, we all know that the change in X over time is the average speed. We know that this change in X over time is the average speed from the definition of velocity. Okay, if we can just look at this, we are going to have what? We are going to replace our change in X over time with the average velocity. If we can just look at that, it's what we have done here. We take as it is and take the average and plug in here. At the end, we're just going to have P average is equals to VF V sub of average. In other words, this is the average power, which is equals to the product. Remember, if you can't have the average power if you don't have work done, that is the amount of work done during a period of time. The time that we're talking about is changing X over T here. But now, because we know that the change in X over T is equals to the average velocity, we just replace change in X over T with the V average. I hope we are still together here. Okay. All right. Let us. Okay. This is an example that we're supposed to work out. All the time I told you that you have to analyze. After analyzing it, you write down the given information as your data. Then you write what is needed. Okay. A locomotive engine of mass 30,000 kilogram has an output or output power of 215 kilowatts. 215 kilowatts. In other words, we have the mass of the locomotive engine, and then we have the output power of 215 kilowatts. Okay, the combined mass of the engine and carriage is 50,000 kilogram. This is 50,000 kilogram, and the locomotive is traveling at a constant speed of 55 meters per second. In other words, we have been given the speed. This is the speed, constant speed. When you deal with the average power, you must know that you are going to deal with the constant speed all the time. That is the constant speed. Now we have a constant speed of 55 meters per second. If you can just look at this, I highlighted the mass of locomotive. I highlighted the output power of 215 kilowatts. We have moved down and look at the combined mass of the engine. That is the combined mass of the engine and carriage. Without what? Without the locomotive. But we have the engine and carriage, which is 15,000 kilogram. Okay, if you can just look at that, I like this because it's along a straight line, level track. That is a straight line. The moment you see a straight line, you must know that this is a primitive lattice. You can just see that, okay, if we are moving straight, we're dealing with the x-axis. We're dealing with the x-axis. Okay, it's where the positive work done comes in and the negative work done comes in. All right, what is the magnitude of the forward force of the train's engine? You have to ask yourself, I highlighted this. What is the magnitude? What is the magnitude? Okay, if you can just look at the magnitude, this is the relative size. Magnitude is the relative size of a, okay, because now we have to calculate the magnitude of the forward force. Now, what is the meaning of magnitude? Magnitude is the relative size of a force. Okay, if you can just look at that, that is 3.1, and then 3.2, if the brakes are applied. In other words, when you apply the brakes, we are going to have a non-conservative force. If you can just look at that on that particular system. If the brakes are applied, what will the power of the braking system be if the train is brought to a complete stop in 40.5 seconds over a distance of 80 meters? If you can just look at that, we have been given, let me highlight something here. The brakes all the time. The brakes indicates the opposite. They're always opposing the motion. That indicates the brakes are always opposing the motion. The moment you see brakes, you must know that you are dealing with the friction. Expect your work to be negative. That is the negative work that we're expecting here, and then we can just go to power. Okay. What will happen? Let me highlight something here again. We have been given time. Time there is in seconds. If it's in meters, in minutes, you have to convert it into seconds. If we have hour, you have to convert that into seconds all the time when you deal with time, because the unit of time is second. Okay, the distance there is going to be measured in meters. We have been given 800. Okay. All right. First and foremost, we have to write down the given as a data. You have to say my data. You have to collect it and put it there. All right. We have mass of locomotive, which is M. Let me say sub of M for locomotive, which is equals to 30,000, which is equals to 30,000 in kilograms. All right. All right. And what else? And what output power? Output power. We have output power. P is equals to, that is 215 kilowatts, 215. Let me just write 50,000 joules instead of K, because I know. All right. Okay. And what else? And what else? The combined of the engine and carriage is 50. We have another mass. We have another mass of combined. Let me just say sub of underneath. Okay, which is equal to 50. Let me double check. Which is 50,000. 50,000. 50,000. 50,000. And what else? We have a constant speed of 55. Constant speed, oh, this one is the in kilograms. We have V, constant speed. That is average, which is equal to, let us look at it. It's 55. 5 meters per second. Meters per second. Okay. What else? What else? What else? Okay, we have to calculate 3.1. 3.1. 3.1. 3.1. Calculate the magnitude of the force of the train's engine. In other words, we have to go back to our formula. We know that P average is P average, P sub of, that is average power, which is equals to the force and the average velocity. If you can just look at that, this one is going to be easy for us because we have the data up there. We have been given the power output. We have been given the velocity. Now we have to substitute with their values. Let us look. P average is 215 kilowatts, which is 215,000, which is equals to the force. And then what about the velocity? The velocity there, average velocity is 55 in meters per second. Or else you can say, I don't want to do it like this. I have to start by saying to making this force to be the subject of a formula. It's allowed as well. If you can just look at that, you can just say F equals to average power over the average velocity, so that you can calculate the force. All right, or you can do it like this. Okay, if you do it like this, you have to make this force to be the subject of the formula is the one that we are looking for. Okay, if you can just say F, therefore F is equals to 2,1500 divided by 55. What are you going to get there? Okay, what I need you to do, Selena, all the time, I need you to use your own calculator. You want to ask your friend when he or she is done so that you can calculate. What I need you to do while I'm busy, you have to do it as well. Okay, you use the same calculator I'm going to use in the exam room. 1, 2, 3 divided by 55. We are going to get, that is 3, average, the force there is 3909.1. In what? In newtons. Okay, what I need you to do. You have to say this is more or less the 3,9 kilo. You have to say kilo Newton. So kilonewton is the same. Is the same. All right. If you can just look at that, we have done with. Let us look. Magnitude of the forward force. Supposed to be positive. Of course, it's positive. All right. Now 3.2. What is it given there? We have 3.1 here. We have 3.2. What are they looking for? You have to look at that. We have time. We have distance covered. If you can just look at that. All right. All right. If you can just look at the power, you can just get that. And then what else? What else? Okay. If you have this 3.2 brakes are applied, what will the power of the braking be if the train is brought to a complete stop in 40.5 seconds over a distance of 800 meters? Okay, in other words, if you can just look at that, we have to look at the formula. That is W now. We're looking for, you have to say W. Let us use the work energy theorem and see. W net, which is equal to change in K, EK. Do we have any value given there? Do we have any value given there? If you can just look at this, we have the force. We have the force, and then do we have masses? Yes, because do we have distance? Yes, we have. Do we have speed? This is a speed, and then we are going to use this formula. Okay. Okay, W net. Let us find the W net. The work net. Let us find the work net. What are we expecting here? We expect the negative because it's where the non-conservative force is acting. All right, W net is equals to the half mv squared minus half the initial squared. If we can just look at that, we have to find the negative. We have to find the negative. If you look at that, we have, which is equals to, we can say the half, which is half. The mass there, the mass supposed to be a combined mass. Is that clear? The combined plus the mass of the locomotive, which is equals to 850 plus 30, which is 80,000. 80,000. The V fine is 0 there because it's just continuing. Is that clear? That is constant. And then minus, let me, okay. Let me just create a space. Let me create a space. Okay. In other words, W net, it should be equal to the half the combined and the mass of a combined, which is 50,000 kilogram, and the mass of the locomotive, which is 30,000. We're going to get what? We're going to get 80, 50 plus 30, which is 80,000. Multiply by, there is 0. Now we have minus half. What about the mass? It's still the same mass, which is 80,000. What about the velocity there? We are going to have what? That is, let's look at it. That is 55. 55 squared. Okay. I can say is equals to, if you can just get there, you're going to get 0. What about that side? You are going to get, let me say, minus 80,000. 80,000 multiplied by half, multiplied by 55 squared, which is minus 1, 2, 1, 1, 2, 1, 0. Let me say, because we have, let me write it in full. 1, 2, 3. 1, 2, 3. And then it's gonna be in joules. Okay. If we have that, what will happen? What will happen? What I need you to do, we have seen that, okay, we are going there to get the negative work done because of the friction. If you have that, we have how many zeros? After one, there will 6 zeros. And we know that this one is represented by mega, that is capital letter M. In other words, we have to say it's minus 1, 2, 1, capital letter M for mega joule. If you can just look at that, this is the capital letter M, stands for 6 zeros after 1. Okay, now we have the work net. What are they looking for? We are looking for, if we have that, if the brakes applied, what will the power of the braking system be? All right, now we have what? We have to go back to the power. The power, we know that the applied, we have the W net. You have to say P is equals to, we know that is W or time. Do we have time? Do we have W? Okay, if you can just look at that, you can say, no, I'm going to use the force. The force applied there. If you want to use, you can just use the force, or you can just, but for now, we have to use the work done over time. We know that the P average is equal to work done during a period of time. All right, let us carry on. Let us carry on. Let us carry on. We have to say it's equals to whatever that you got then is negative. You can't, negative there indicates that the work there, it works under the influence of friction. That is why we have negative 121 megajoules. Okay, if I can do that, I can say this is 1 to 1 divided by 1, 2, 3, 4, 5 divided by, what about the time? The time given there, it's what? The time given, we have to look at the time given. The time given then is 40.5 in seconds. In seconds, 40.5. That is 40.5. If you can just look at that, Let me extend the page, which is equals to, I need you to use your calculator while I'm busy using mine. All right, let us do this together. 1, 2, 1, 2, 3, 4, 5, 6, divided by 40,5. All right, what we are going to get there, we are going to get, that is 2, let me say 2 comma, let me write it as it is so that you can just see what I'm doing. 54,3. All right, in what? This is once. All right, which is equals is the same as 2, let me say 3. You will see what I'm doing here. Let me say 3 is the same as 3, capital letter M. Okay, let me do it like this. Is 2, 9, 8, 7. Let us leave it like that. If I can just go, let us leave it like this. Or you can say, let me just put it 2.3. Let me just say 3. This is 3. 3 megawatts. Okay, let me put it like that. Let me just correct it. It is 3 megawatts. All right, where is it coming from? I just move 1, 2, 3, 1, 2, 3, 4, 5, 6. If you can just look at that, I just took this to the other side into 3. All right, that is 3 megawatts. All right, if we have that, I hope we're still together. Let me try to move fast. Let me try to move fast. Okay. We have this exercise. We have this exercise. I can just give you only 3 minutes. Let me say 3 minutes. 3 minutes to do this one. 3 minutes to do this one. Let me highlight some of the things. Okay, during the first, this is your exercise. I need you to do it on your own. I'm giving on 3 minutes from now. At the same time, if you don't have, I'll be reading. Okay, during the first 0.60 meter, produce average upward pull on barbell weighing 214 kilogram of 3,800 Newton. All right, the positive work done on the, we have these 2.3 kilojoules, while the negative work done by the pull of the earth on the barbell is 1.4 kilojoules. If you can just look at that, we have a positive work done and a negative work done. Okay, what is it given then? We've been given the distance, that is 0.60 meter. We're also given the mass of 214 and the force there, which is 380 Newton. That is the average. All right, the average, we talk about what is it needed then? The average power of the weightlifter if they achieves the first, this, okay, the first 0.60 meter of hair lift in 0.32. If you can just look at that, we also have been given the time. We also have been given the time. We are left with a minute. We are left with a minute so that we can just finish this. Okay. We all know that P average, we know the formula. I need you to do that quickly. Okay. Because of time, what I need you to do, you have to go back to the formula of power, which is P is equals to W over T. We all know that W there is equals to B, F, and distance over time. If we can just look at this, we have what? We have a distance and we have a time and a force. Force there is 380. The distance there is 0.60 divided by time. Time is 0.32. If you can just do that, you are going to get 7.2 kilowatts. Okay, that is your answer. If you have some problems, you can just, we shall see this tomorrow. That is number B. That is number B. But I gave you the formula. I gave you everything that you're supposed to use when it comes to this problem. Okay. Firstly, you have to write down the given information. What are they looking for? And then you can just look at what is given there so that you can just go straight to the formula of your choice. Which formula are you going to use? This time we have the average power. We don't have anything that we can use. That is P average, which is equals to change in X over time. You just go there. Your force is 3,800. Then multiply by 0.60 divided by 0.32. Then you can just get number B. Thank you very much for today. See you tomorrow while we continue with our power. All right. Bye.